I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast, the week starting Sunday, November 29th. Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, real data for outdoor people, all the time, no hype. Looking at significant wave heights in the North Pacific Ocean, we have an obvious bit of good news. A storm is pushing over the dateline with 57-foot seas aimed east and southeast at targets both in the United States, mainland, and the Hawaiian Islands. This is a great way to get into the holiday season. As usual, we'll start looking at jet stream level winds. These winds of about 30,000 feet help support the formation of gales, and when they do form, help direct their track. We're looking for a trough, just like that here, a dip in the jet stream a little bit to the south, and you can see 190 knot winds are pushing east in a consolidated jet stream flow off Japan to the dateline, forming this little dig out right here, this trough, and that helps set up a counterclockwise flow aloft and down at the ocean surface, and that is the hallmark of low pressure. If that trough is deep enough and strong enough, it creates winds. If the winds are strong enough, they generate seas, and if the seas are high enough, as they radiate away from the fetch area, they turn into swell, and eventually that swell produces waves when it hits our beach. All right, so we definitely have a trough being supported by good winds pushing off Japan, and obviously we have a storm on the dateline, so that's really great news. East of there, the jet splits. You see one stream going south, pushing over like Baja, Southern California, and the more energetic stream pushing off to the northeast, creating a second little trough up here south of Alaska, but pretty pinched off, not doing a whole lot to support gale formation. Then typically in between these split flows, you get high pressure, which is right here, which has made literally cloud-free skies in Northern California for multiple days in a row now, and beautiful temperatures and beautiful conditions, but would be nice to see some rain. All right, so let's put this into motion. Moving into Monday, the trough continues, if anything, building with 200 knot winds pushing into it as the trough pushes over the dateline towards the western Gulf of Alaska, continues on that track with a really just a beautiful looking jet over the western Pacific into Tuesday and even into Wednesday, still solid with some sort of a trough hanging right here in the western Gulf of Alaska with that split flow, actually a triple split flow, and high pressure holding over California. We get into Thursday, it's more of the same. If anything, a new trough starts digging out. Now, not with as much wind. You can see 150 knot winds feeding, but still, that's great for gale production. And that continues into Thursday and Friday as a new trough spins through the Gulf of Alaska into Saturday, and still just massively consolidated, solid 170 knot winds pushing over the dateline into, well, where are we now? Into Saturday, new trough, Sunday filling the Gulf of Alaska and the dateline region into Monday. So really, this doesn't get much better than this. A solid week of a very favorable jet stream flow aloft should do a lot for producing storms. All right, let's go take a look down at the surface. As expected, here's our storm, not a gale, a storm with 55, actually almost 60 knot winds sitting over the North Dateline region. Fetch well south of there, well positioned, aimed off to the east. And as we get into Monday, the system does start to fade with 45 knot winds, but covering a broad area, looking pretty good, targeting not Hawaii directly, but close enough. I mean, the magnitude of this system should send serious swell into the islands. And of course, the main target is the U.S. West Coast. All right, into Monday, the gale continues 35 to 40 knot winds. And then it finally starts fading out on Tuesday morning. A little bit of a break, but we know there's a big trough still sitting here. And then as we get into, I think it's Thursday or so, another gale starts building here off the U.S. West Coast. Not a very big one. And another one west of the dateline. So we'll talk these both at the same time. So we get in Friday morning, almost 50 knot winds in the gale off the U.S. West Coast. 45 knot winds on the dateline gale. Building on Saturday both with 55-knot winds aimed off to the east. You think there's going to be some swell from that if the model verifies? Pretty impressive. Saturday morning, just a good amount of fetch aimed southeast and east. Just, the colors tell the story, I guess, in this case. Don't even want to try to overhype it. It just is what it is, if it materializes. So we get into Sunday, the main gale starts fading out, 45 to 50 knot winds, but still holding into Sunday night with 40 to 45 knot winds in the northwestern Gulf. Significant swell likely to result. All right, let's go take a look and see the effect of those winds on the ocean surface. So we're going back in time just a little bit to Friday, 2 days ago. A little gale developed just barely south of the Aleutian Islands, built into Saturday with 38-foot seas. That's the highest seas in this entire domain here. 38-foot seas aimed off to the east, and then it started pushing east and fading out on Saturday night. Swell from this system is poised mainly for the U.S. West Coast, but maybe a little bit of sideband energy dribbling down into Hawaii on Monday. And also Saturday night, we're calling this storm number 1, the first significant class storm of the 2020-2021 winter season, started developing west of the dateline, seas at 45 feet. On Sunday morning, building to 53 feet. On 18Z Sunday, that's about 10 a.m. West Coast time, seas were 57.7 feet modeled. We'll see if the Jason 3 satellite makes a pass over this area and if we can get some readings from it, but odds are probably typically pretty low of that, but you never know. We might get lucky. All right, let's move to the forecast. All right, looking forward, Sunday evening, seas still 55 feet on the dateline. You see the arrows, most energy pushing to the east, but a good amount. I mean, when you have a storm this strong, energy radiates over a good spectrum from the east, southeast, maybe even south. Moving into Monday, the seas fade, still 50 foot. This is 24 hours solid, maybe more like 28 hours of 50 feet or greater seas. That is solid indeed. Moving into Monday night, seas start dropping 43 feet. And into Tuesday morning, the gale starts fading out with residual 34-foot seas in the western Gulf of Alaska. Now, how far is that from 1, 2, 3? That's 900 miles north of Hawaii. And quite a bit further, probably like 1,800 miles away from the U.S. West Coast, and dissipating from there. Most of this is just literally raw seas. In fact, we'll go back. Here we are. Tuesday evening, 27-foot seas over a broad area. That is, there isn't even hardly any fetch left there, so it's not being generated. That's just the raw swell pushing east, in a very in a raw state, in an ungroomed state. But that as it gets groomed, serious number of waves per set are expected into the U.S. West Coast. All right, moving into Wednesday, things settled down for just a little bit, even into Thursday. Still a rather disturbed pattern, but nothing organized until we get into Friday. We'll go right to Friday evening. Our 2 new systems set up. This is an upgrade, actually. This one off the U.S. West Coast is now forecast to have, 30, 32, 34, 36, maybe 37-foot seas, and a new dateline storm with about the same thing, quickly both ballooning up into Saturday, but the one on the dateline takes over 49-foot seas, the one off the U.S. West Coast, what is that, about 38-foot seas. The one on the dateline continues moving into the western Gulf, while the more easterly one starts pushing off to the northeast, fading 46-foot seas. And then look at this, rebuilding on Sunday, again with 48-foot seas in the northwestern Gulf of Alaska. Sunday night, then dissipating 43-foot seas. And fading from there. We're 180 hours out, and it's just non-stop action the whole way. Gotta love this. All right, a quick look not at winds in terms of wind swell production, but just conditions for Hawaii and the U.S. West Coast. Sunday, light winds on the U.S. West Coast. Sort of northeast trades for the Hawaiian Islands, not too strong, but kind of kind of bumping things up a little bit. On Monday, a little bit stronger northerly flow for California, 10, maybe 15 knots. And trade still kind of that east-northeast direction for the Hawaiian Islands, but then turning pure east as we get later into Monday, as winds pick up along the California coast. Here we go into Tuesday morning. You think there's some fetch in the Gulf of Alaska, filling the whole area. Tuesday, we'll call it north winds along, north to northwest winds along the California coast. Little pockets of less winds, but it's like 15 knots. Light winds on Tuesday for the Hawaiian Islands. Not even barely trades. Call it 5 knots. Can't ask for a better situation as swell starts arriving from storm number 1. As we get into Wednesday, winds still a little brisk along the California coast. We'll call it 10, 15 knots. Light trades for the Hawaiian Islands. And then as we get into Thursday, winds, we'll call them 10 knots along the California coast. Light wind regime over the Hawaiian Islands. And into Friday, more of the same thing, light winds California. Now, the issue is, notice this low just north of Hawaii. Will that set up a wind event there? Right now, it's kind of hard to tell. Way too far in the future. Here we are. We'll call it Saturday morning. Light winds again along the California coast. So maybe south winds up at Cape Mendocino. Trades start picking up for the Hawaiian Islands at 15 knots. Sunday, again, not a horrible situation for California. Light northwest winds, maybe 15 knots at Point Conception, some exposed spots. Trades for Hawaii or southeast winds, maybe 15 knots. Where are we here? We're just out to, there we go, 180 hours out, almost to Monday. Northwest winds pick up for California as high pressure builds, and a sort of a southeast wind flow for the Hawaiian Islands. So plenty of opportunities without horrible winds for the next coming swell. All right, quick look at precipitation potential for California. We have swell. We don't have, there is snow on the ground, but the short of it is, here's the closest to rainfall we're going to get in California. It's on Monday for just a second over Cape Mendocino, and that's it. Then we're just going to blast through this. Notice this high pressure just locking everything down, that split jet stream flow. Nary a cloud for the California coast. We're into Saturday, Sunday. How far can we get here? There we go, 180 hours and nothing, no change. Lots of activity in the Gulf of Alaska, but it's like there's just this barrier right here. Cannot get through into California. Likewise, snowfall potential, we're looking at Squaw Valley here, but it's representative of just about all of California. Nary a drop to be had. Snow level, or the freezing level, if you will, a little bit lower today. What is it, 9,000 feet, but then it goes up to 12,000 feet, and for the most part stays that way for the foreseeable future. Not good for even snow making because it's too warm. All right, let's go take a look long term. What's going on with the Madden Julian Oscillation and, of course, the El Nino Southern Oscillation. As usual, we're looking for signs of the active phase of the MJO. The MJO, the Madden Julian Oscillation, has 2 phases, active and inactive. When in the active phase, and when the active phase is over the Pacific, it helps impart energy to the jet stream. A stronger jet stream then helps dig out troughs and helps support gale formation, and that in turn makes surf. All right, so we're looking at, this is data from the TAO buoy array, series of buoys strung across the equator. This is the East Pacific here, West Pacific here. These buoys are used for monitoring El Nino, the formation or lack of El Nino. We're only looking at the arrows though. These are 5-day average winds. You see the arrows are coming from the east, representing strong trades over the East Pacific, the Central Pacific, and then the West Pacific, what we call the Kelvin wave generation area. If the active phase is over this area of the Pacific and it's strong enough, it can actually reverse the trade winds and then take warm water that's here, start pushing it off to the east in the form of a Kelvin wave. That is a subsurface pool of warm water. If you get successive active phases of the MJO and successive Kelvin waves, that can help usher in El Nino. Of course, we do not see any of that happening right now. Strong easterly winds over the Kelvin wave generation area does nothing for Kelvin wave production. But it is anomalies, the differences in normal for this time of year. Sometimes of the year, the trades are just naturally strong. We're looking at the arrows again. You see little bits of small east arrows suggesting the trades are a little bit stronger than normal, but not that bad in the East Pacific, building a little bit over the Central Pacific, and then moderately strong to strong over the Kelvin wave generation area. So this does not suggest the active phase of the MJO. It suggests the inactive phase of the MJO. And given that, and given the fact that we have at least one massive storm already in the water, it's kind of a head scratcher, but like we've said before, when we talk about La Nina and the inactive phase of the MJO, it does not mean that you can't have storms. It just means that the probability of them occurring are weaker or less. And clearly, this is a case of that contradiction. Next up, we look at the wind forecast. All right, so this is the whole, and this is just the east-west component of the wind. It's not the actual wind. It's just, are the winds blowing stronger from the east or stronger from the west than normal for this time of year? All right, so whole planet on one chart, the date line runs right up the middle. So the Pacific starts about 135 east, so right about there, and goes to about 80 west. That's down on the equator only. That's Ecuador roughly there. Kelvin wave generation area starts from here and goes to about here. The blues and purples, easterly anomalies. And you can see even from late October, we've had a steady diet of easterly anomalies. They got a little bit weaker there in, we'll say, early November. And then somewhere about mid-November, they just set up and they are just nuking and forecast to continue to blow quite strong the whole way through the end of the model run. This is only 1 week out, so like December 6th. Right, let's dig a little deeper. All right, so what's the MJO supposed to do over the coming 2 weeks? This is a chart called outgoing long wave radiation, OLR, fancy words for sunlight reflectivity off the ocean surface. If you have more clouds, then you get less reflectivity, and that typically is associated with the active phase of the MJO, and that's what we want to see. According to this model, the active phase is somewhere over, what are we looking at here? There's the equator running right across there, South America, Central America, Australia, New Guinea, Kelvin wave generation area right here. This is where we're interested in. We want to see the active phase over this area because that will impart energy to the jet stream and feed the storm track and feed storm production. So right now, not a whole lot going on, but supposedly 5 days from now, weak active phase of the MJO moving over the Kelvin wave generation area, continuing for 10 days, 15 days out. That's pretty good for the statistic model. Now the dynamic model, not so encouraging, just basically saying a continuation of the same thing or maybe a weak active phase trying to barely limp into the Kelvin wave generation area, 10 days, 15 days from now. But you know what? That's better than having the inactive phase in control. Let's dig a little bit deeper. This chart, what is this? Phase diagram. What's that mean? Well, see that circle there? Assume you're looking down on the North Pole, okay? And the Earth rotates underneath the chart, and the MJO travels from west to east on the equator, from the Indian Ocean over the maritime continent, through the West Pacific, East Pacific, under the United States on the equator, over the Atlantic, over North Africa, back to the Indian Ocean. Where the heavy dot is where the active phase of the MJO is. So, maritime continent, let's say like Bali, that area. But the further away from this circle the dot is, the stronger the active phase of the MJO is. So, it's inside the circle, exceedingly weak, and here is the forecast here. So, it's supposed to move into the West Pacific, this per the statistic model, 15 days from now, and very weak. Now, the dynamic model here, the Cfs model, suggests the active phase is to stay over the maritime continent, maybe getting a little bit stronger, but still pretty weak and not going anywhere. So neither one of these is particularly great news. Let me take a look at the upper level model, all right? This is areas favorable or not favorable for precipitation. 40 days out, there's South America, Central America, the equator right there, West Pacific over here, there's New Guinea, Australia. So Kelvin wave generation area right in here. The greens are areas favorable for precipitation, so one would say the active phase of the MJO, working its way across the Pacific and then stalling somewhere in the East Pacific on, about Christmas time, something like that. So this is a good window here the next month for storm production, followed by a weak inactive phase, theoretically starting about, mid-December, it making its way about to the same place in the Pacific and then dying too on January 8th. At that time, another active phase starts building in the West Pacific. Neither are strong, neither are cohesive, kind of a weak MJO pattern. And then the 1 month CFS model, all right? Same deal, whole planet on one chart, the date line running right up the middle. So our area of interest, the Kelvin wave generation area, starts right about here, 134 east to about 170 west. That's the other side of the Kelvin wave generation area. Here's where we are today. Blues are easterly anomalies. The dotted contour is the inactive phase of the MJO. So we see the inactive phase of the MJO right starting to fade in the Kelvin wave generation area. Strong easterly anomalies in control and forecast to continue into maybe December 8th. They moderate for a little bit. And then as we get to about December 19th or so, easterly anomalies kick up again. Also notice the purple shading here, the dotted contour. That is a high pressure bias. It is the fundamentals for La Nina. La Nina is in control this winter. And so we don't see any sign of the active phase of the MJO. It would be like that, but we need it over the Kelvin wave generation area. We're not seeing it. The last active phase we had was back here in late October. Nary a sign of it since. That is not unusual with La Nina in control. But again, even with La Nina, even with no active phase, we have storms on the charts. So, this is not this MJO thing is not always a guarantee. And then finally, the 3-month CFS model. Now this is again, whole planet on one chart, but this is past performance here. The forecast is here. And the one thing that really grabs your attention is massive amounts of strong easterly anomalies right in the center of the Kelvin wave generation area. Again, that goes from about here to about here, something like that. Okay, but we do see some westerly anomalies in the very far reaches of the west Kelvin wave generation area. So let's overlay the MJO. Here we go. Okay, so the dotted contour here is the inactive phase of the MJO. That's supposed to continue in the Kelvin wave generation area to about mid-December. Then an active phase, very weak, sets up, ushering in some weak westerly anomalies. A massive easterly wind burst is forecast in the January timeframe, late December, January timeframe, but another stronger active phase forecast at the same time makes westerly anomalies, but only barely makes it into the Pacific and then fades. So it's hard to say how all this is going to play out. Notice this looks like a strong active phase of the MJO. Well, this one at one time was very strong, looking like that. And the closer you get to it actually happening, it gets progressively weaker. So hard to say. Looks like La Nina pattern for sure. Let's overlay the low-pass filter. Now here's the scary part, or maybe it's the good part depending on how you look at it. So the dotted contour is the high-pressure bias. This is like the La Nina signal. The solid contour is a low-pressure bias. Right now, it is in the Indian Ocean, smack dab in the Indian Ocean, where high pressure is in control of the Pacific at a very macro level. And we're at 2 contours, supposedly moving to 3 in December, then to 4 in mid-January, and then to 5 in late January. This is a definite uptick in the strength of La Nina for this one run of the model. We'll see what happens in a day or two, but I think the intensity in this is going to tick downward. And then also 2 contours for the low-pressure bias in the Indian Ocean. That again, also seems like an overstatement because the model's never really hinted at anything more than 1 contour. And then no real, where is that? The difference between the two, about 140 east, no budging anywhere, which sort of smells like we're moving into a 2-year La Nina event here. And just a quick look at Mjo activity for 2020. So this doesn't say where the active phase of the Mjo is. It just states the intensity of the active phase. So like in, I guess, February of this year, we had a strong active phase of the Mjo. But since then, it's been exceedingly weak. You can compare it to even last year, where we had stronger active phases. And then in 2018, yeah, about the same as 2019. And then when was the last really good? There we go. 2015. Comparatively, look at the strength of the active phase in that year. Active phases in that year, and then that. Gosh, notice this. 2017, almost nothing until we got into the beginning of 2018. Anyway, the point being, very weak Mjo pattern has been going on for the most part of this year. All right, let's move on then to not so much the Mjo thing now. Let's talk about El Nino La Nina. We start by looking at what the ocean is doing, not the ocean surface, but down in the ocean. So this is data from the TAO buoy array. This is the West Pacific here. This is the East Pacific here. These are the anchor lines on the TAO buoys strung across the equator, and the X's are sensors on those anchor lines. They're used to collect data. You use a model, fill in the gaps, and you get a profile of subsurface ocean temperatures. And you see this is in centigrade, 29 degree isotherm in the far West Pacific here, 28 degree isotherm. It's been holding steady about 177, 175, something like that for a couple of weeks now. And the 24 degree isotherm at 135 west, and that's where it's been. But you can clearly see warm water in the West Pacific, not so much in the East Pacific. And let's look at anomalies, differences from normal for this time of year. And you clearly see colder, 3 degrees centigrade below, so that's about 5 degrees Fahrenheit below normal, filling the entire East Pacific to the date line, I think is, well, we'll just go look. Whoops, right there. Okay, filling to the date line, and even then some warm water, 1 degree above normal, confined to the far West Pacific and making zero headway this week or any week in the past month or two. All right, another model. This is a higher res model, we believe. Again, painting the same picture, but showing warmer temperatures. 1, 2, 3, we'll call it 4. 1, 2, 3, 4. So maybe 2.5 degree anomalies. Again, confined to the far West Pacific. 160 is the cutoff with 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. So, 5 or 6 degree below normal. That's 7, 8 degrees below normal in the core, and basically cold water filling all the East Pacific. No surprise, because trades are blowing much harder than normal. That creates upwelling, and you get no Kelvin waves, so warm water stays confined to the West Pacific, and that is the hallmark of La Nina. Then we put this sort of on a timeline so you can see what's been going on. This is the West Pacific here, East Pacific here. Time going down the scale here, all this year. December 2019, you see the last Kelvin wave of whatever that was prior to where we are now, trying to make its way across the Pacific into March of this year, and it died. And then massive cold upwelling, trades kicked in. Got a good burst there in May, June, kind of backed off for a month. And then starting in August, it's been nonstop, strong trades, massive upwelling with a, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Supposedly a pocket down to 2.5, almost 3 degrees below normal. Again, this is upper ocean 300 meters, so it's sort of averaged over a broad depth, but it clearly shows you where the core of the cooling is. California is about 122, so just a bit west of California. We take a quick look at ocean surface temperatures now. We've seen what's going on subsurface, so it's no surprise. The blues are cooler than normal temperatures. This is not actual temperatures. It's a difference from normal for this time of year. But clearly you can see, so there is South America. This is Peru and Ecuador right in here. Galapagos right in there, or there, depending on how you want to look at it. And you see cold water the whole way out to the date line, completely in control of all of South America. This is a classic La Nina kind of signature. Trades much stronger than normal, driven by high pressure in the southern hemisphere, stronger than normal. It flows counterclockwise. Here's the trade wind pattern. The North Pacific, same deal, but flowing clockwise, and the trades converge right in this area here, and that's why you get your upwelling. Then looking at the trend, just the past 7 days, and we're just looking right here on the equator. You see the blues, cooling temperatures here off the Galapagos the whole way out to about 140 west, 145 west. There's Hawaii, and then it's more of a balance of interspersed warming and cooling, but the focus of the cooling right here. And you can see that pretty well here. See this band of much cooler than normal water. Well, this is where the 7-day trend has been suggesting almost consistent cooling every week. You can see it there. You know, there's actually been a little bit of warming down in this area here, but it's the area, the official El Nino monitoring region starts at 120 west, goes 5 degrees north and south of the equator out to 170 west. So you draw a box in your mind right there. And you can see in that entire area, temperatures are cooler than normal. The Nino 1.2 region is right around in here. It's more just, it's a noisy region, but it kind of gives you an early warning of what might be happening out here. And then our Kelvin wave generation area that we use is from 135 east out to 170. So here, so basically, Kelvin wave generation area, official El Nino monitoring region, early warning El Nino La Nina monitoring region. That's how we're doing it. Sea surface temperature anomalies in the Nino 1.2 region, the area right there by the Galapagos in Peru. Today, minus 1.225 degrees, so definitely way below normal by 1.25 degrees. The trend slowly working its way up, and then that's what we said when we looked at the sea surface temperature anomaly charts. It's not as concentrated there in the Nino 1.2 region as it's been, but still temperatures are pretty cool. Then we go take a look in the official El Nino monitoring region, the Nino 3.4 region. Temperatures today, minus 1.253, right there. What's the trend? Well, they were dropping down hard, and then in November we kind of got a rebound from a weak active phase of the MJO, and now they're just kind of holding steady. I mean, it's not good, but at least it's not, it's certainly not neutral, certainly not positive, but it's not falling off a cliff either. And then the final component of El Nino does what, so we talked the MJO component, right? And we know that basically the active phase of the MJO just isn't happening. If anything, the inactive phase seems to be in control all the time. Easterly anomalies stronger than normal, all that kind of thing, creating upwelling. Then we looked subsurface. We saw a well-established pocket of, well, not a pocket. The whole East Pacific is full of colder than normal warmer water driven by the strong easterly trades and upwelling. Then we looked at the ocean surface, saw the exact same thing, a well-defined cool tongue of water on the equator from Ecuador out to the dateline and beyond. Then the final thing we want to look at is the atmosphere above the ocean. Is it responding? Does it sense that there is cold water, and is it supporting high pressure in the Pacific? All right, so we look at the Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti. If pressure is lower in the Pacific, the Tahiti numbers will go lower, and that'll drive the index negative. Today, we're at plus 19.40, so it's clearly not negative. Negative would be either the active phase of the MJO, if it's a short run of negative numbers, or long term, it would be El Nino. But all we're seeing for the most part here is, for the past month, nothing but positive numbers, and pretty strongly so, suggesting at least the inactive phase of the MJO. 30-day average, 8.98. Working its way up and probably going to be heading up more, suggestive of the inactive phase of the MJO, if not perhaps La Nina. The 90-day average actually down a little bit, 7.58, and you can see, you can kind of go back here, it's been 7 to 8 for a month. So it's holding steady, but we suspect this is going to start rising. Somewhere hit the 12 or maybe even the 15 mark, depending on how strong this La Nina gets. All that means high pressure in control of the Pacific. And then finally, the official sea surface temperature forecast from the CFS version 2 model for the Nino 3.4 region. That is the official El Nino monitoring region. There's good news here, at least in this run of the model. So here we are today. Temperatures are about 1.25 degrees below normal according to the model. That's in late November. And you see the forecast has it going down to maybe minus 1.5 degrees. Well, even last week we were down, it was supposed to go to minus 2, and 2 months ago it was supposed to go down to minus 2.5. This suggests that maybe this La Nina isn't quite as strong right now as we were thinking it was going to be. And also notice that it's supposed to rebound and return to almost neutral temperatures as we get into July, mid-July or so. So maybe some encouraging news here, or maybe it's just some anomaly with one run of the model. We'll have to give it another week or two before we know for sure. But it seems like the long-term trend, the trend line for the model is it's softening up each time and making this La Nina a little bit not as bad as it was originally supposed to be. All right, so the good news is storm number 1 is in the water, generating 57-foot seas as of right now, all that aimed towards Hawaii and the U.S. West Coast and even down into South and Central America. So large, long period swell looks pretty likely given where we're at. And then looking out, the models suggest a small storm and then another strong storm right behind that. Aimed a little bit, pushed a little bit more to the east, maybe more in the Western Gulf, something like that. But still, one storm for sure, and maybe another strong one on the charts. That's good. Take it for all you can get, because clearly we are in La Nina now. Now, what's even more interesting, these storms are forming during the inactive phase of the MJO, and it's a strong inactive phase of that. But again, the MJO thing, you can't always bet on it. It's a general trend. We also have this sort of off-the-wall theory that says that it's not so much the active-inactive phase or La Nina, El Nino, but it's when you're in the middle where your weak El Nino, weak La Nina, that sort of thing, and the atmosphere just doesn't have any direction, that you don't get storms. But when you're on the extremes, when you're strong El Nino or strong La Nina, then maybe the atmosphere wakes up. No data to support any of this, just a theory, unproven, untested. But I think we're going to get a little run of it here in the next month or two and see if it really holds any weight. All right, so that's it for this evening. If you enjoyed the video, give us a thumbs up. Where we are. There's a thumb up. If you haven't subscribed, please subscribe. You'll get email notifications when we post the video. If you have any questions, post them in the comments section. We'd love to hear from you. And if not, that's fine too. All the data you've seen tonight is available at stormsurf.com. You can go there, follow along during the week, come watch the video. We post a link to the video on the site at the top of the top header page of the site, every page of the site. Come click that, watch the video, test your knowledge, see how you're doing. And we hope you're getting smarter, and we hope you're enjoying it. All right. So anyway, that's it for tonight. We'll do it again next week, same time, same channel. Go get some surf and be safe. Thank you.